Okay. We'll continue with this question. Part F, so this is still question 2, I believe, and it's part F, is find 90% confidence interval for the proportion of students who spend 25 hours or more per week. Okay, so it's confidence interval. The question is confidence interval proportion. Now, confidence interval proportion, we use this. We use P plus or minus Z star PQ over N, where this is whatever comes, like all confidence intervals, they have the plus minus in them. And whatever comes after the plus minus is called ME, or margin of error. Okay, so let's find one thing at a time. We need, what is Z star at 90% confidence interval? You can use websites, you can, like in Google, if you say Z at 90% CI, it will tell you right away what it is. But the way you're supposed to do it is you take 90% and you add half of alpha. Alpha would be whatever left. So you need 90% plus half of 10%, and that gives you 95. And this percentage you need to look up. So you go to the Z table, you go inside the Z table to look for the closest to 95. You'll see that in the middle of the table there is 9495, and there is also 9505. That's in the middle of the table. This one corresponds to 164. This one corresponds to 165. Your 95 is in the middle between them. So eventually it's 1645. Or again, you can just put it in Google and that will tell you exactly what it is. Okay, so we found what Z star is. We need P. Now they tell you people spending more than 25 hours. So you go back to the list that you have. More than 25, so we start counting for the 26. There are about 24 numbers out of the 48 actually exceeding, so that's 50%. So the percentage here is 50%, the numbers exceeding the value of more than 25. So more than 25, that would be 24 numbers out of total. Now, I really want to change this a little bit, and I'll tell you why, because I want to show you the difference. So I want to make it, well, we'll continue with this. So your P is 50%, your Q is 1 minus P, 50%. So it happens to be 50%. I was hoping for a better number. So now we put everything in the formula. So you go 50%. We know your Z is 1645. And you take the 50% times 50% over N. And your n in this case would be the sample of 48. So we put everything in the formula. So now we do it in two steps. So 50% plus or minus, we do the margin of error. The margin of error in this case 1187. So your estimation for pi, which is the true proportion, is between, you add these two, you minus these two. So we're going to minus them, takes you down to 3813. You add them, and takes you up to 6187. Good? Now, you're asked to, well, even if you're not asked to, you always have to interpret this in English. So you always have to interpret the confidence interval. Anytime you see a confidence interval, you need to interpret the what this means in English. The way she likes interpreting this, I'll just erase some of this. Since you're 90%, you say in 90% of confidence intervals based on 48 students, that's the sample, the true proportion of students spending time on social media it's the question, it's a proportion of who spend more than 25 hours. Yeah, the true proportion of students spending time more than 25 hours in social media is between, and you put the two percentages, 3813 and 6187. And since we're 90% confident, you have to say in brackets, there is 10% chance of error. So basically you start with n, whatever the confidence interval level, based on whatever the sample is, the true proportion of whatever the question is between the two numbers you found, and since you're 90%, 10% chance of error. Okay, I'm gonna erase this. Now, the question now, so remember, we found P to be 10%, 50%, sorry, and 50%. Now, suppose that you want to estimate the proportion to within plus or minus 10%, what sample size, or how many students? When you're asked for how many, or sample size, formula for sample size is Z star over ME squared PQ. That's if your sample size proportion, like this question, let me see, estimating proportion. If you ask for sample size, average, or mean, we use Z standard deviation ME all squared. Don't worry about this one, we have this one. Now for this one, there are two ways of doing it. There is the new way, where you have access to previous information. So your Z star, since we're still at the same confidence interval, they didn't tell you to change, so it's still 1645. The margin of error, as I told you, it's whatever comes after the plus minus, and in the question, you have plus minus 10%, so I know it's 10%. And then PQ, we have access to the previous information, so we can use the 50 and 50 we found. So we do this, 1645 over 10% squared and 50/50, you get 67.65. Whatever you see after the decimal place, even if it's 0.1, you always round up. So sample must be 68 students. This is the new way. The old way of doing this is if you have no access to previous information. In this case, you would still use the 1645, the 10% squared. You don't have access, you assume that it's 50/50. So it's a little bit silly here because, like, imagine that they asked a question and you found P to be 30%, Q 70%. So in the new way, you would use the 30 and the 70. In the old way, you always assume it's 50/50%. But in this case, they match. The old way and the new way, they match, so it doesn't matter. Question is, which way do we do in the exam? If he mentions do it the new way, or if he mentions assume access to information, do it the new way. If he mentions no access, do it the old way. If he doesn't, I'll do it both ways. Okay? You'll see that I also sent you another question from a previous final exam. So that's just to cover as much information as possible. So also one of her old exams, I'm going to erase this. So the question here, the director of the CRA, taxpayer, waiting time, and the sample of 25 taxpayers. They give you everything, and they ask you in the first question what level of measurement. Again, since they're all time, and I think it's in minutes, they say times in minutes, so that's ratio. IQR, we did a question like this. I want to start with question 1C. 99% confidence interval for population average. So it's confidence interval for average or mean. We did the confidence interval proportion P plus or minus Z star square root PQN. For average, you have two choices. Either X bar plus or minus T star S over square root of N, or you can do Z star sigma over square root of N. You do this one if sigma is known. What is sigma? Sigma, remember, is the standard deviation of all and must be given. You can't calculate sigma. So in the question, if they tell you, for example, assume that the standard deviation of time for all taxpayers for the population of taxpayers is 4, for example, then that's sigma. So sigma would be the standard deviation of all. But sigma unknown, which is, like say 90% of the time, you would use the t version. So in the question, there was no mention of what the standard deviation of time for all taxpayers is, so we don't have sigma, we'll use the t version. So x bar plus or minus t star s over square root n. Now, to do this, we need t star. To get the t star, we get it from t table. We need degrees of freedom, that's n minus 1. Sample is 25, minus 1, 24. And alpha, if it's, they ask for 99, alpha is always what's left. 1%. You divide it by 2 because it's a two-tailed system. And all confidence interval, by the way, all of them two-tailed. So the idea of one-tail, two-tail, when you start doing hypothesis. But for confidence interval, they're all one-tail. Two-tail, all confidence interval two-tail. So you can use the t-table she provides, or you can use any t-table from the internet, it doesn't matter. So I'm going to use one from the internet. So you just type t-table from Google. So they're all the same. If you go to the degree freedom 24, if you go to the degree freedom 24 and 005, you'll see that your number is 2.797. So eventually your T star 2.797. So we have T star. I need to find my mean, my average. That's the sum of x over n. I'm given the sum, it's 697.3, and I know that n is 25 numbers. 697.3 over 25, that's 27,892 minutes. I also need to find my standard deviation, and to find my standard deviation, we follow the 3 steps. Total variations, where it's sum of x squared minus the sum of x squared over n. You're given both of them, that's 24,06593. Sum of x is 697.3 squared, and all of this over 25. So 24,06593, 697.3 squared over 25. This number is 46168384. I need my variance, where I take this over n minus 1. So I divide it by 24. That gives me 1923683. Standard deviation is square root. So you square root this number. That's 13,8697. So I'm going to add it here, my standard deviation 13.8697. So now we found everything, the mean and the S and all of that. So I can put everything in my confidence interval formula. Mean is 27,892. My T star is 2797. My standard deviation 13.8697. And it's the square root of sample 20. So again, you bring the first number down. You only do what comes after the plus minus. So 13.8697 times 2.797 square root of 20. This number is 86745. So your estimation for mu, you minus them, gets you down to 19,2175. You add them, gets you to 365665. Now, to do this in English, you say, and like we did for the previous one when we explained the proportion, you say in 99% of confidence intervals based on a sample of 25 tax payers, the true mean, and whatever the mean is, this is true mean or average waiting time is between 19,2175, 36,5665 minutes. We're 99, so there's 1% chance of error. Good? Or 1% chance of being wrong. Same thing. Okay. Let me erase some of this. So we did the confidence interval, and we know it's between 19 and 36 minutes. And the next question, the CRA wants to tell taxpayers that the average time is 25 during the last week of April. Can this statement be made and why? Could the average time be 25? Is 25 within confidence interval? You say yes, it's within confidence interval, so wait or mean wait time could be 25 minutes. If they say, could it be 40 minutes? You say no, can't be 40 minutes, it's outside or not within confidence interval. But that's if you're given a number. So could it be 25? Could it be 30? Could it be 40? What if they tell you, is this statement true? Mean time is at least 25 or more than 25 minutes. So they don't specify a number, they say at least, or it could be more. According to this, uh, yeah, it's possible that it's more, but it could also be less. So can you know for sure that it's always at least 25? No. It could be less according to CI. So according to our CI, it could be less. But if they say at least 18 minutes, you say, yeah, waiting time is at least or more than 18 minutes because both numbers more. So if they say more than 18, yes, for sure. But more than 25 or more than 30, no. And if they ask for a specific number, it just needs to be within confidence interval. Okay. What assumptions needed to do part C? When you're asked for assumptions, you have to assume, or we prefer that you say the sample of taxpayers must be randomly selected. But if they mention in the question that it was already randomly selected, you don't worry about it. And if you go back and you read the question in line 3, a random sample. So we already know that it's random sample, so it's redundant. The second one, do you remember, did we use the T star confidence interval or did we use the Z star? We used the T star. In this case, you have to say the sample of taxpayers must be approximately normally distributed since sigma is unknown. So yeah, that's if you use a T. But if you happen to use this one, what would change in the assumption? The first one is always there, randomly selected. But when you do the second one, must be, you don't use the word approximately, you use must be normally distributed since sigma, no. So for the Z star, random and known. For the T star, approximately normal, and it's unknown. There is also a probability question, but we did that. We did all of the work, so I'll leave that for you to do. And let me see what else I want to do from this question. Yeah, two things. First of all, there is the outlier. I want to do the outlier question. Are there any outlier in there's the way of doing the outlier, and I showed you in the previous example how to do the outlier. But there is two different ways of doing outlier. So it doesn't matter which way you like, it's all good. Now, are there any outliers in the data provided? So we go back to the question. To do the outliers, we needed Q1 and Q3. I really don't know again which way she's doing this, so I'll stick to this way. As I told you, it could either be n over 4, 3n over 4, or n plus 1, n plus 1. So sample is 25, 3 times 25 over 4. This one we need the number that's in 1875. And if you, this one is the 1875. And if you do the first one, it would be the number in 625. This one, you take the sixth number, which is 4.9. You add 25% of the difference between the seventh and the sixth. Seventh is 17.4, and the sixth is, they're in order going down, sorry. The numbers are in order every time you go down. So we need the sixth number, which is 13.8, plus 25% of the difference between 6 and 7, 17.4, 13.8. This would be 14.7. I'm doing it the same way I did it in the previous example. The number that's in the 18th position is 39, plus 75th of the difference between the 18th and the 19th. And that would be 39.6. Then your IQR is Q3 minus Q1, 39.6, 14.7. $24.9. So we do lower fence, upper fence. Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. Here we must be less, here we must be more. So Q1 is 14.7 minus 1.5 of 24.9. Your lower fence in this case is minus 2265. Your upper fence 13.6 plus 1.5 of 24.9. Your upper fence is 7695. To be or to have outliers, we must be less than minus 22.65. We don't have anything less. To be an upper outlier, we need to be more than 7695. We don't have anything more. So no outliers. Nothing more, nothing less. Good. Another way of doing this, like a quick way to do this, and this is only if you, let's say, for example, that mu is 25, sigma is 10. Let's assume that, for example, for the same question. If they ask you is, or a taxpayer waited 45 minutes, is that an upper outlier? Or a taxpayer waited 7 minutes. Is that a lower outlier? Instead of doing the IQR and all of this, if you're given a number to test outlier, do it this way. Find this Zx minus mu sigma. So for example, for a 45 minus 25 over 10, that gives you 2. And do it also for the other one. For the 7, minus 25 over 2 minus 1/8. If the value more than 3 or 3 or more, then it's upper outlier. If your value is equal or less than -3, would be lower outlier. In this case, it's 2, so it's good, not an outlier. Here it's -1/8, also good, not an outlier. So we're good in both cases. That's if they want you to test quickly for a certain number. The other question that I wanted to do, or the other part that I wanted to do, at 95% confidence intervals, estimate the number of taxpayers needed, or sample size, 95 confidence interval to estimate for mean, to estimate number of taxpayers needed, which is sample size, with plus minus 1.5 or margin of error 1.5. Assume sigma is 10. Okay, so I told you this when we did it in the previous question, estimating sample size for proportion. We gave you the formula and we told you there is a new way and old way. When you do sample size and it's for mean, confidence interval mean, we use this formula. ZS over ME squared. Now 95 confidence interval, of course this is Z star. Z star at 95, I told you how you do it. You take this, you divide it by 2, you take the 95 plus half of the remaining, it would be 975, and you go look it up. Or you just put it in Google. Just say Z at 95% CI. It will tell you right away that it's 196. Here, if you have sigma, use it. If you don't, use the S you calculated earlier. Remember, we calculated S to be 13. So we either use 10 if given, sigma given, we use it. If not, use the calculated standard deviation 13.869, the one we did. The margin of error is whatever comes after the plus minus. I gave it to you in 2 different ways, so 1, 5, and you square. So this would be 170738. Doesn't matter what number is, you always round up. Sample size is 171 taxpayers. Okay, so this is basically all you need to know for the first test. So I did questions from 2 different tests. I'm going to send you the questions that I did, and I'm also going to send you the Z table if you like, or you can use the one you have, it's up to you. And that's it. If you have any questions, you can let me know, and good luck.